Understanding the electrical code and its proper application is paramount for ensuring safety and compliance in electrical installations. When discussing electrical work, accuracy in referencing the code and specifying components is essential. Discrepancies or inaccuracies can lead to misunderstandings, incorrect installations, and potentially hazardous situations. In the context of ground fault circuit interrupter or GFCI installation, it is important to consider several factors. Firstly, the electrical code dictates specific requirements for GFCI protection in various locations, particularly in areas where moisture is present, such as bathrooms, kitchens, and outdoor receptacles. These requirements are outlined in the National Electrical Code, (ONEC), and adherence is crucial for preventing electrical shock hazards. Secondly, when installing a GFCI receptacle or breaker, it is important to ensure compatibility with the existing wiring system. In the scenario mentioned involving 12/3 and 12/2 wiring, it is crucial to understand the conductor configuration and intended use of each cable. A 12/3 cable typically consists of a black hot wire, a red hot wire, a white neutral wire, and a bare ground wire, while a 12/2 cable includes a black hot wire, a white neutral wire, and a bare ground wire. The presence of two hot wires in the 12/3 cable indicates that it may be used for a multi-wire branch circuit, where two separate circuits share a common neutral conductor. In such cases, special considerations may be necessary when installing a GFCI to avoid nuisance tripping or improper operation. Thirdly, when installing a GFCI in the same electrical box as 12/3 and 12/2 wiring, it is important to ensure that the wiring connections are made correctly and that the GFCI device is properly grounded. Incorrect wiring can result in the GFCI failing to function as intended, leaving the circuit unprotected. Additionally, it is important to verify that the electrical box is of sufficient size to accommodate the wiring and devices without overcrowding, which can lead to overheating and potential fire hazards. In general, when working with electrical systems, it is always advisable to consult with a qualified electrician or electrical inspector to ensure that the installation meets all applicable code requirements and safety standards. These professionals have the knowledge and experience to properly assess the wiring system, select appropriate components, and perform the installation in a safe and workmanlike manner. Furthermore, it is important to remember that electrical work can be dangerous, and it is never worth risking personal safety to save time or money. If you are not comfortable working with electricity, it is best to leave the job to a qualified professional. Let's delve into some specifics regarding GFCI protection and wiring configurations. The National Electrical Code, specifically Article 210.8, outlines the requirements for GFCI protection in dwelling units. It mandates GFCI protection for 125V through 250V receptacles supplied by single-phase circuits rated 15A and 20A in specific locations. Some of these locations include bathrooms, garages, outdoors, crawl spaces, unfinished basements, kitchens, sinks, boathouses, and laundry areas. The purpose of GFCI protection is to detect ground faults, which occur when current leaks from a hot conductor to ground. This can happen if someone comes into contact with a live wire or a faulty appliance. When a ground fault is detected, the GFCI trips the circuit, cutting off the flow of electricity and preventing electrical shock. A GFCI device typically operates by monitoring the current flowing through the hot and neutral conductors. If there is a difference of more than 5 mA between the current flowing in these conductors, the GFCI will trip. This is because the difference in current indicates that some of the current is leaking to ground. There are two main types of GFCI devices: GFCI receptacles and GFCI circuit breakers. GFCI receptacles are installed in place of standard receptacles and provide GFCI protection only at that specific location. GFCI circuit breakers are installed in the electrical panel and provide GFCI protection for the entire circuit. When installing a GFCI receptacle, it is important to follow the manufacturer's instructions carefully. The receptacle will have terminals for connecting the hot, neutral, and ground wires. It is important to connect the wires to the correct terminals to ensure that the GFCI functions properly. When installing a GFCI circuit breaker, it is also important to follow the manufacturer's instructions. The breaker will have terminals for connecting the hot, neutral, and ground wires, as well as a pigtail wire that must be connected to the neutral busbar in the electrical panel. Regarding the 12/3 and 12/2 wiring configurations, it is important to understand their intended uses and limitations. As mentioned earlier, a 12/3 cable typically consists of a black hot wire, a red hot wire, a white neutral wire, and a bare ground wire. This type of cable is commonly used for multi-wire branch circuits where two separate circuits share a common neutral conductor. In a multi-wire branch circuit, the two hot wires are connected to different phases of the electrical panel, which provides 240 volts between them. The neutral wire carries the unbalanced current from the two circuits. A 12/2 cable, on the other hand, consists of a black hot wire, a white neutral wire, and a bare ground wire. This type of cable is typically used for standard 120 volt circuits. It is important to note that when installing a GFCI on a multi-wire branch circuit, special considerations are necessary. Because the two circuits share a common neutral conductor, a standard GFCI receptacle may not function properly. This is because the GFCI monitors the current flowing through the hot and neutral conductors, and if there is current flowing in the neutral conductor from both circuits, the GFCI may misinterpret this as a ground fault and trip unnecessarily. To overcome this issue, it is necessary to use a two-pole GFCI circuit breaker, which protects both circuits simultaneously. A two-pole GFCI circuit breaker monitors the current flowing through both hot wires and the neutral wire, and it will only trip if there is a ground fault on either circuit. In addition to GFCI protection, it is also important to ensure that the wiring system is properly grounded. Grounding provides a path for fault current to flow back to the electrical panel, which helps to trip the circuit breaker and prevent electrical shock. The ground wire should be connected to all metal enclosures, such as electrical boxes and appliance chassis, to ensure that they are properly grounded. It is also important to ensure that the grounding system is properly connected to the earth. This is typically done by connecting a grounding electrode conductor to a ground rod or a metal water pipe. The grounding electrode conductor provides a low impedance path for fault current to flow back to the electrical panel, which helps to trip the circuit breaker quickly and prevent electrical shock. Finally, when working with electrical systems, it is important to follow all applicable safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and rubber gloves. If you are not comfortable working with electricity, it is best to leave the job to a qualified professional. Let's also discuss arc fault circuit interrupters, or SIs. While GFCIs protect against ground faults, SIs protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. They occur when electricity jumps between two conductors, creating a spark. This spark can ignite nearby flammable materials, such as wood or paper, causing a fire. SIs are designed to detect arc faults and trip the circuit, cutting off the flow of electricity and preventing a fire. The NEC requires SI protection for all branch circuits that supply 120-volt, single-phase, 15-amp and 20-amp outlets installed in dwelling units. This includes bedrooms, living rooms, dining rooms, family rooms, and other similar areas. SIs are available in two main types, of SI circuit breakers and of SI receptacles. SI circuit breakers are installed in the electrical panel and provide SI protection for the entire circuit. SI receptacles are installed in place of standard receptacles and provide SI protection only at that specific location. When installing an SI circuit breaker, it is important to follow the manufacturer's instructions carefully. The breaker will have terminals for connecting the hot, neutral, and ground wires, as well as a pigtail wire that must be connected to the neutral busbar in the electrical panel. When installing an SI receptacle, it is also important to follow the manufacturer's instructions. The receptacle will have terminals for connecting the hot, neutral, and ground wires. It is important to connect the wires to the correct terminals to ensure that the SI functions properly. One common issue with SIs is nuisance tripping. This occurs when the GFCI trips for no apparent reason. Nuisance tripping can be caused by a variety of factors, such as faulty appliances, loose wiring connections, or electromagnetic interference. If you experience nuisance tripping with an GFCI, it is important to troubleshoot the problem to determine the cause. You can start by checking the wiring connections to make sure they are tight and secure. You can also try unplugging appliances one at a time to see if one of them is causing the problem. If you are unable to determine the cause of the nuisance tripping, it is best to consult with a qualified electrician. They can use specialized equipment to test the circuit and identify the source of the problem. In summary, electrical safety is of utmost importance, and understanding the electrical code is essential for ensuring safe and compliant installations. When working with electrical systems, it is always advisable to consult with a qualified electrician or electrical inspector to ensure that the installation meets all applicable code requirements and safety standards. Remember to follow all safety precautions and never take risks when working with electricity. Firstly, ensure accurate referencing of the electrical code and components. Secondly, understand GFCI protection requirements and compatibility with wiring systems, including 12/3 and 12/2 configurations. Thirdly, properly ground the wiring system and follow all applicable safety precautions. Finally, consider side protection to prevent arc fault hazards and address any nuisance tripping issues.